Hello, and welcome to this lesson on the compounds formed when halogens react with metals and nonmetals. In today's lesson, we will firstly describe the nature of the compounds that are formed when halogens react with nonmetals. We will explore the compounds formed when halogens react with metals. So far, we've talked about the reactivity and electronic structure of the halogens. You have learned that halogens are highly reactive nonmetals with 7 electrons in their outermost shell. This makes them likely to gain one more electron in chemical reactions to achieve a stable electron configuration. Building on this foundation, today's lesson, we'll examine how the unique properties of halogens influence the types of compounds they form with metals and nonmetals. When we talk about the reactions of halogens, which are elements in group 7 of the periodic table, with other substances, we can classify these reactions based on whether the halogens are reacting with metals or nonmetals. These reactions lead to the formation of specific types of compounds. Halogens can react with nonmetals by sharing electrons. This sharing of electrons allows both the halogen and the nonmetal to achieve stable electron configurations. The result of this sharing of electrons is the formation of molecules. This type of bonding is known as covalent bonding, which we will examine in greater detail in a later unit. Let's take the example of hydrogen, a nonmetal, reacting with chlorine. Each hydrogen atom has 1 electron, and each chlorine atom has 7 electrons in its outer shell. When they react, they share electrons to form a molecule of hydrogen chloride, HCl. In this case, each chlorine atom shares 1 electron from the hydrogen atom and one of its own electrons to form a single covalent bond, resulting in a HCl molecule. Halogens react with metals in a different manner. Instead of sharing electrons, the reaction involves the transfer of electrons from the metal to the halogen. This transfer of electrons allows the metal to become a positively charged ion and the halogen to become a negatively charged ion. The result is the formation of ionic compounds known as metal halides. Again, we'll look at ionic bonding in much more detail in a later unit. Consider the reaction between sodium, a metal, and chlorine, a halogen. Sodium has 1 electron in its outer shell, and chlorine has 7 electrons in its outer shell. Sodium transfers its 1 outer electron to chlorine. This electron transfer allows sodium to achieve a stable configuration by becoming a positive ion, and chlorine achieves stability by becoming a negative ion. The attraction between the positively charged sodium ion and the negatively charged chloride ion forms the ionic compound sodium chloride, NaCl. In today's lesson, we explored the nature of the compounds formed when halogens react with metals and nonmetals. In summary, when halogens react with nonmetals, they form molecules through the sharing of electrons. The halogens share electrons with nonmetals to achieve a full outer shell of electrons. This results in covalent compounds like hydrogen chloride, HCl. We also learned that when halogens react with metals, they form metal halides through the transfer of electrons. These halides then combine with positively charged metal ions to create stable ionic compounds. This results in ionic compounds like sodium chloride, NaCl.